Alright, here's a problem for you. Solve for x, for ax squared plus bx plus c equals 0. Now, there's no numbers in here. What are you going to do? Can't factor it because we don't have any numbers. So let's use our completing the square that we learned the other day. So first let's move c over to the other side. And then let's divide everything by a. And then let's complete the square. So we need to half b over a. That means I'm going to take b over 2a, because that's half of b over a, and square it. And I'm going to add that to both sides. So b over 2a all squared to both sides. On the left, we can factor that to x plus b over 2a all squared. And on the right, we can simplify a little bit. This is going to be negative c over a plus b squared over 4a squared. And in order to add my fractions, I need a common denominator. So that means that if I'm going to square this a, I need an a up here. And if I want a 4 down here, I need a 4 up here. So now I've got x plus b over 2a all squared equals, and then we have minus 4ca plus b squared. But I think I want to put the b squared part first, and then I'm going to say minus 4ac. And then I'm going to put it all over 4a squared. And I'm trying to solve for x, so now it's time to take the square root of both sides. We've got x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. So that's plus or minus the square root of b squared minus 4ac on top, and then divided by the square root of 4 is 2, and the square root of a squared is a, and this is x plus b over 2a over here. Oops. Sorry, 2a right there. So I want to get x by itself. I need to subtract b over 2a. So negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since we have a common denominator, I'm going to put it all together. And I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. That looks vaguely familiar. I think I've seen that before somewhere. Okay, so that brings us to today's video about the quadratic formula. And the quadratic formula goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, hey, wait, that's where I've seen that before. That's crazy. So now we know where it came from. Alright, and then a lot of you learned this to the tune of Pop Goes the Weasel, so, you know, if that's what you gotta do to know it, that's fine. But my 6-year-old even knows that song, so you guys better know it in your pre-AP high school math class. Now, an important part of this quadratic formula is this part right here underneath the radical sign. b squared minus 4ac only. That's one single number. That's what we call the discriminant. Not to be confused with determinant from the matrices chapter, but it's called the discriminant. And that tells you what kind of answer you're going to have. If b squared minus 4ac is a positive number, then you know you're going to be taking plus or minus the square root of a positive number, which gives you two real answers. And you could break that down into rational or irrational, depending on if you could take the square root of it or not. Okay. If b squared minus 4ac equals 0, well, the positive square root of 0 is the same thing as the negative square root of 0. It's all 0. So you just have one real solution. And it would be rational. And if your discriminant is negative, then you're going to try to take the square root of a negative number, which you know can't happen, or actually can. You'll get an imaginary solution. You'll get plus or minus, so you get two complex or imaginary solutions. And since imaginaries aren't rational or irrational, you don't have to break it down that into one of those. Alright, so let's try one. Here's a quadratic. It says solve for x. The first thing you always have to do when you're solving a quadratic is set it equal to 0. So that means I need to combine like terms and get this equal to 0. So we'll take away 7x squared from both sides, and we'll take away x from both sides, and I've got 12 minus 7 is 5x squared. Don't mind my dog in the background there. And then we have minus 4x, and then we have plus 2 equals 0. So now A is 5, B is negative 4, and C is 2. And I'm just going to plug these into the quadratic formula. So we've got x equals, and if I say negative b and then b is already negative, I'm going to basically take the opposite of b. So we're going to say 4 plus or minus the square root of b squared, so I'm just going to go ahead and write 16, minus 4ac, so minus 4 times 5 times 2, all over 2 times 5, gives me 4 plus or minus the square root of 16, and then 4 times 5 is 20 times 2 is 40, all over 10, and give me just a second. So we have 4 plus or minus the square root of negative 24 all over 10. So if I said, what is the discriminant? You would just look at the number underneath the radical sign. Don't take the square root of it, but the discriminant is negative 24. And because it's negative, we know that when we take the square root of it, we're going to have an imaginary, or two imaginary solutions. So the discriminant here tells us that the number of solutions is 2, the type is imaginary, but we learned yesterday how to solve imaginaries, so now we're just going to keep going. Alright, 24, the square root of 24, that breaks down. The perfect square that goes into 24 is 4, so we've got 4 plus or minus, and then that would be take out an I for the negative, take out a 2 for the 4, 2i, and then you have a root 6 left, all over 10. And since this is supposed to be real plus imaginary, we've got 4/10, which is 2/5, plus or minus, and you see how this 10 goes with both the 4 and the 2i root 6. So 2 over 10 is 1/5, so I've got I root 6 over 5, real plus imaginary. So that means we've got two complex solutions. Okay, kids, this last example is a word problem. It's your favorite kind, I know. So I'm going to read it to you just in case you can't read. It says, Mrs. Butcher, the world's most famous basketball star, shoots a basketball. When the ball leaves her hands, it is 7 feet from the ground, because she has a really high jump. When it reaches the basket, it is 10 feet from the ground. She throws with an initial velocity of 30 feet per second. Use the thrown object formula to determine how much time passes from when the ball leaves her hands to when it hits the net. So I'm going to draw a picture of this. Alright, so right here, that's 7 feet, and right here, that's 10 feet. And obviously I didn't draw my horrifically awful stick figure drawing to scale, but you'll get over it. Alright, so now we're going to take these values and we're going to plug them into the thrown object formula, which I haven't given to you yet, but that is going to be h equals negative 16t squared plus vt plus s. And t is your time in seconds, and v is your initial velocity, and s is your starting height. Alright, so we're going to take a starting height of 7 feet. We're going to take a time that we're solving for with our ending height of 10 feet, and then our initial velocity of 30. And we're going to plug that all in and see what we get. Alright, so h equals negative 16t squared plus vt plus s. Our height is 10 feet at the basket. We don't know t, but the initial velocity is 30, and the starting height is 7. So we now have a quadratic that we need to solve. And of course, to solve a quadratic, it has to equal 0. So we're going to subtract the 10, and 7 minus 10 would be negative 3. Alright, then we take this and we use these for A, B, and C. So I forgot my equal 0. And plug them into the quadratic formula. Instead of using x, we're using t, but it's the same thing. So we're going to say our time equals negative b, so negative 30, plus or minus the square root of 30 squared minus 4 times negative 16 times negative 3, all over 2 times negative 16. So let's clean those numbers up a little bit. So here you get negative 30 plus or minus the square root of 708 all over negative 32. So our discriminant is 708. That's a positive number. That tells us that we're going to have 2 real answers. Another thing that the discriminant can tell us is if there are going to be rational solutions or irrational solutions. Well, the square root of 708 is not a perfect square, so it's irrational. That means we're going to have 2 solutions, but they're both going to be real, but they'll be irrational. They won't be nice, pretty whole numbers, or even pretty fractions. So when I give you something like this, I will let you use your calculator. So now you need to punch in negative 30 plus the square root of 708 divided by negative 32 and the minus. And magically you will get t equals 0.106 and 1.769. Now, why on earth are there 2 answers? Well, let me bring back the picture of me shooting the basketball. And it won't let me bring just the picture. It's making me bring all the words and numbers with it, but that's okay. Here it is. And if you notice, at 10 feet, right here where the basket is, that parabola actually hits that value twice. So at 0.106 seconds, the ball is on its way up. And then at 1.769 seconds, the ball's back on its way down, and that's when it hits the net. So if we want to know when it hits the net, we would say 1.769 seconds. And that concludes today's lesson. Here's a little treat for you guys.